Okay, Amma. Good morning, students, all of you. I hope that you had understand the last day class. I have teach some sums of exercise 7.2 based upon the concept substitution method. Based upon the concept substitution method. Okay. Now let us revise the concept and we will proceed for today's sums. Integration. See, yesterday I have taught you the method of integrating a function by using substitution. What is the use of substitution method is, if an integration was given to you and we cannot solve the integral directly by applying the formula or by inspection method. If we cannot solve the integral either by inspection or by directly applying the formula, we will substitute some part of function. As t, assume as t, and we convert the total function in terms of t. And after that, the given integral will be converted into easier form, which is easy for integration. After substitution, the function converts into new variable. Which is easy to integrate, which is easy for integration. Okay, that is the use of substitution method. The name substitution came because we are assuming some part of function as t and converting in terms of new variable. It is, suppose we generally converting in terms of t, so it is said to be substitution method. Now let us see some problems. Exercise 7.2. See the question here. 13th sum. Integral x square by 2 plus 3. My exercise 7.2 13th sum. X square by 2 plus 3x cube whole cube. Integral x square by 2 plus 3x cube whole cube dx. Now see here. Now let us assume, let us suppose first what to think that is t. See here, the function which is inside this, if you assume this as t, the derivative of this function it is in terms of square root, in terms of second degree. Hence it is third degree equation. If you do it derivative, we will get second degree. In the numerator there is second degree equation. So for us it is better to assume the thing which is inside the bracket as t and we can proceed. Okay, now let us 2 plus 3x cube equals to t. 2 plus 3x cube equals to t. Now do derivative on both sides with respect to variables. Derivative of 2 it is 3. Derivative of 3x cube it is 3 into 3x square dx. 3 into x cube. Derivative of x cube it is 3x square dx equals to dt. Okay, now what is here? Here it is only x square dx. Keep x square dx aside and send all other to that side. Then what it will be? X square dx equals to dt by 9. X square dx equals to dt by 9. In the place of x square dx, substitute dt by 9, and in the place of 2 plus 3x cube, put t. The given function totally converts in terms of t. Okay, in the place of x square dx, put dt by 9. 1 upon. In the place of 2 plus 3x cube, you can put t. Okay, see here the total function was converting in terms of t. Now 9 is a constant, take it out. Integral 1 by t cube. 1 by t cube dt. 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 See here, it is of the form 1 by t cube. We can write like this: t power minus 3. T power minus 3 dt. T power minus 3 dt. See here, it is resembling the formula integral x power n. What is the integral x power n? It is x power n plus 1 by n plus 1. Integral x power n, it is x power n plus 1 by n plus 1. Apply the formula here. 1 by 9 into t power minus 3 plus 1 by minus 3 plus 1. Minus 3 plus 1 by minus 3 plus 1. 1 by 9 into t power minus 2. T power minus 2 by minus 2. T power minus 2 by minus 2. See here, 1 by 9 into minus 2, it is minus 18. T square, t power minus 2, it is equals to t square. See here, we applied the integration. Up to this step, we did the steps related to substitution. Here only we applied the integration. Okay? Then we have to put c here, from here. Okay? Now, how t is related to x? By this relation, t is related to x. In the place of t, put what you assume. It is nothing but, what is your final answer? 1 by minus 18 t, 1 by t square. 1 by t square. What is t square? 2 plus 3x cube. 2 plus 3x cube whole square. Okay? This is the way how to solve a integration by some kind of integration by substitution method. We cannot follow this method for any integration. For one particular cases only we can follow this method. See here, which is inside the bracket, we have chosen it as t. With respect to variables, we did the derivatives. Here derivative of 2, it is 0, 3 into x cube, it is 3x square dx. For t it is dt. 3 into 3 it is 9. I said it 9, that's it, because here we need only x square dx. X square dx is equals to dt by 9. In the place of x square dx, I substituted dt by 9. In the place of 2 plus 3x cube, I have written t. 1 by t cube. 1 by t cube dt. 9 is a constant, I sent it out. Now 1 by t cube can be written like this, t power minus 3. It resembles the formula integral x power n. What is the formula for x power n? It is x power n plus 1 by n plus 1. In the place of n, it is minus 3. T power minus 3 plus 1 by minus 3 plus 1. It is equals to t power minus 2 by minus 2. 9 into 2, it is 18. 1 by t square. Okay? In the place of t, substitute 2 plus 3x cube whole square. 2 plus 3x cube whole square. This is the final answer. Okay, see the steps here once again. Okay. Next, see the question. Integral 1 by 1 minus tan x. Integral 1 by 1 minus tan x dx. Integral 1 by 1 minus tan x dx. See here, let us solve little bit trigonometrically, and after that we will follow the integration. Solving little bit trigonometrically, in the place of tan we can write sin x by cos x. Sin x by cos x. Okay. Now what it will be? Don't forget dx. It is I'm writing the direct step here. Cos x by cos x minus sin x. I hope that you understand. Cos x into 1, it is cos x. Cos x into 1 dx. See here. One by 1 minus see here, 1 by 1 minus tan x. It can be write like this: 1 by 1 minus sin x by cos x. See here, cos x by sin x minus cos x minus sin x. Okay, ma. For this little trigonometry, it is required. See here. Now let us find somewhat easier than this, and we will try this sum. See here. See the question, 35th question. One plus log x. 1 plus log x by x. 1 plus log x by x whole square. 1 plus log x by x whole square. Okay, see here. Substitute integral dx. Integral dx. Integral 1 plus log x whole square by x dx. Okay. If we substitute 1 plus log x, if we substitute 1 plus log x equals to t. Previous sum, after discussing particular concept, we can solve that sum. 1 by 1 minus tan x. After finishing the concept, we will try to find the answer for that question. 1 by 1 minus tan x. Okay. Now it is based upon previous concept. By solving this question, we will move to the previous question. Okay. Now 1 plus log x by x whole square. See here. If we put 1 plus log x equals to t. If we put 1 plus log x equals to t, apply derivative on both sides with respect to variable. It is 1 by x dx. It is 1 by x dx dt. 1 by x dx dt. See here. In the place of dx by x, in the place of dx by x, we can substitute dt. In the place of 1 plus log x, we can substitute t. In the place of 1 plus log x, we can substitute t, and in the place of dx by x, we can substitute dt. See here, the total integration will convert to this form. In the place of 1 plus log x, we can put t square into dx by x, it is dt. Dx by x, it is dt. In the place of 1 plus log x, we substituted t. In the place of dx by x, we substituted dt. Okay. Now it is of the form integral x power n. It is of the form integral x power n. What is the formula for integral x power n? It is x power n plus 1 by n plus 1. It is integral x power n plus 1 by n plus 1. T power 2 plus 1 by 2 plus 1. Integral t power 2 plus 1 by 2 plus 1. After finishing integration, we have to add plus c. We have to add plus c. Next, it is t power 3 by 3. T power 3 by 3 plus c. In the place of t, substitute the given value. 1 plus log x. In the place of t, substitute the given 1 plus log x whole cube by 3. 1 plus log x whole cube by 3. See the steps here once again. What we did, we substituted in the place of 1 plus log x as t. Apply derivative on both sides with respect to variables. We got 1 by x dx. Here the total integration was converted in terms of t. What is the formula we require here? T power n formula. What is the formula for t power n? It is t power n plus 1 by n plus 1. This is the okay. This is the process to solve. t power 2 plus 1, it is t cube by 3. Okay, ma? Now let us move to the next sum. See the 36th sum, exercise 7.2, 36th sum. Exercise 7.2, 36th sum. It was a little bit lengthier. See here. X plus 1 into x plus log x, x plus log x whole square, total upon x dx, total upon x dx. See here, which thing we have to assume as t? Now, if we think this as t, x plus log x, what is the derivative for that particular thing? X plus log x, for x it is 1, for log x it is 1 by x. It will be of the form 1 plus 1 by x. See here, x plus 1 by x, what it, if we do solvation up to from some steps, what will be, this is equals to 1 plus 1 by x. See here, if we think this as t, derivative of this thing here, seen here. So it is better to think this as t. Okay. X plus log x equals to t. What is the derivative with respect to variables on both sides? It is 1 plus 1 by x dx equals to dt. 1 plus 1 by x dx equals to dt. See here, 1 plus x and dx, this both it will be equivalent to dt, and in the place of x plus log x we can put t, integral t square dt, integral t square dt, it is equals, it is of the formula, it looks like the formula integral x power n. What is the formula for x power n? X power n plus 1 by n plus 1. Integral x power n plus 1 by n plus 1. T power 2 plus 1 by 2 plus 1. Now after you did the process of integration, you have to put c here. Next, t power 3 by 3. What you have to put in the place of t? X plus log x whole cube by 3, whole cube by 3. See the steps here. Okay, next. Now let us see the previous sum, because this sum and previous, these both are connected, interrelated. By solving that, we can solve this question easily. Now we will do the previous sum which we left before. See the 33rd question. See the 33rd question. See the 33rd question. See the 33rd question, but it is somewhat lengthy. Don't get confused. 1 by 1 minus tan x. 1 by 1 minus tan x. We keep it trigonometrically, we will solve that, and after that we will think what we have to do for easy solving of integration. Okay? See here, in the place of tan we can write sin by cos. 1 minus sin x by cos x. 1 minus sin x by cos x. Next step. Cos into 1. 1 by cos x minus sin x by cos x by cos x. Cos x minus sin x by cos x. If cos x goes to denominator, it will be like this. Cos x by cos x minus sin x. Dx is getting carried on. Dx is getting carried. But it is lengthy. Solve carefully. In the place of tan, we written sin by cos. Cos into 1, it is cos. Cos minus sin by cos. Cos goes to numerator. Okay. See here a little adjustment is there. Can we bring denominator in numerator? See here. See the step carefully. You multiply and divide with 2. You multiply and divide with 2. You will know why we are doing like this. You will know why we are doing like this. We are multiplying and dividing with 2. See here. 2 cos x by cos x minus sin x. See here. In order to make denominator in numerator, we want to see denominator in numerator. We want to see denominator in numerator. For that particular thing, see here, can we write like this? For 2 cos x, we can write like this. Cos x plus sin x plus cos x minus sin x. Cos x minus sin x. See here, it is algebraically equals to this. This is algebraically equals to this thing. See here, cos plus cos, 2 cos x plus sin x minus sin x. They both will get cancelled. They both will get cancelled. It is equals to 2 cos x. It is equals to 2 cos x. Nothing wrong algebraically. Why we are doing like this is, we want denominator in numerator. We want denominator in numerator. For that we are doing like this. Cos x minus sin x. Cos x minus sin x. 1 by 2 into. This will come under this and this. This will come under this thing and this thing. What will happen? Cos x minus sin x. See here. Cos x minus sin x by cos x minus sin x. It is equals to 1. First of all, I am dividing this with this thing here. It is equals to 1 because they both are same. They both are same. Otherwise, let us prolong the steps. Cos x minus sin x by cos x minus sin x plus cos x plus sin x by cos x minus sin x. Cos x minus sin x. Okay, see, I hope that you all of you understand. Dividing the numerator with denominator. This will come under this and this. It will be like this. They both get cancelled. They both get cancelled. It is equals to 1 by 2 integral 1 plus 1 by 2 integral 1 plus, listen, see here carefully, integral see here, Here we have to do the substitution method. Here we have to do the substitution method. See here. What is the derivative of this particular thing? For cos x, derivative of cos x it is minus sin x. For minus sin x it is minus cos x. If we take minus, if we think derivative as t, denominator as t, and we do the derivative this particular thing, derivative of this, if we take minus common, we are getting the numerator. We are getting the numerator. So if it is easy for us to think this as t. If you think denominator as t, it is easy to solve. Next, now cos x minus sin x equals to t. Cos x minus sin x equals to t. Apply derivative on both sides. Apply derivative on both sides. What is the derivative of cos x? It is minus sin x. What is derivative of minus sin x? It is minus cos x into dx equals to dt. Equals to dt. Minus sin x minus, for cos x derivative is minus sin x, minus derivative of sin x it is cos x, dx equals to dt. We can take minus common and send to that side. Take minus common here and send to that side. It is equals to minus dt. It is equals to minus dt. See, if dx was carrying forward, dx, here also dx. Okay. Now see here, while solving this particular thing, we require the substitution method. We require the substitution method. In the place of sin x plus cos x into dx, we can put minus dt. We can put minus dt. In the place of cos x minus sin x, in the place of sin x plus cos x, sin cos x minus sin x, we can put t. We can put t. See the steps carefully. We can put. Now apply the integration formula. 1 by 2 into. Here, what is integral 1? Integral 1, it is x. Be careful. Here with respect to dx we are doing. Integral 1 dx, it is x. It is x. Okay? Plus. Here we are doing with respect to dt. It is minus, it will come out. Integral 1 by t, it is log t. It is log t. 1 by 2 into x. Here with respect to dx, it is x. Plus 1 by t, it is log t. Minus it is outside, it will be like this. Okay, we applied the formula of integration. We have to put plus c. Now further one more step is there. I will have it. If you want to note, you can note. See here. See the final answer here. What we have assumed in terms in the place of t, 1 by 2x minus log. In the place of t we have to substitute cos x minus sin x. In the place of t we have to put cos x minus sin x. Cos x minus sin x plus 1 by 2 into x minus log of cos x minus sin x. This is the final answer. Based upon this model, there are 2-3 sums. Okay? Previously, 2-3 sums they are alike, and these 2-3 sums now next sum also will be alike like this. Okay? Okay. Now let us move to next. integral x cube, integral x cube sine of it's look like complicated, but it is very easy. X cube sine of tan inverse x power 4 by 1 plus x power 8 by 1 plus x power 8. See here, x cube sine of tan inverse x power 4 by 1 plus x power 8. If we assume tan inverse x power 4 as t, tan inverse x power 4 as t, what is the derivative for tan inverse x? It is 1 by 1 plus x square. 1 by 1 plus x, we will get the exact this thing. Okay? Now, see here, tan inverse x power 4 equals to t. Tan inverse x power 4 equals to t. Apply derivative on both sides with respect to variables. With respect to variables. Apply derivative on both sides with respect to variables. We will get here 1 by 1 plus x square. X square it is x power 8. Tan inverse x 1 by 1 plus x square dx equals to dt. Equals to dt. Okay? Come on, here one thing you have to do, should not do wrong. Tan inverse x power 4, here you have to apply the formula 1 by 1 plus x square. In the place of x, it is x power 4. That's square, and derivative of x power 4. Then what is derivative of x power 4? It is 4x power 3 dx. Be careful here while doing the derivative. Tan inverse x power 4. Think this as x. 1 by 1 plus x square, this square, into derivative of that particular thing. What is derivative of 4x power 4? It is 4x cube dx. It is 4x cube dx equals to dt. Equals to dt. Here, in the place of x cube dx 1 plus x power 8, you can substitute dt by 4. You can substitute dt by 4. X cube dx keep aside. 1 plus x power 8 aside. Send 4 to that side. Dt by 4. Dt by 4. X cube by 1 plus x power 8. X cube by 1 plus x power 8. It is equals to dt by 4. And it is equals to sine of this thing. It is equals to t. Integral sine t dt by 4. That complicated sum become easy by substitution. The complicated thing become easy by substitution. So henceforth, here we got the logic. Which thing we have to substitute? Here, assume if you know the formulas of derivative. See, you imagine yourself in your mind. If you think this as t, what is the derivative for this particular thing? 1 by 1 plus x square. Like that you memorize in your mind, and after that you think. Next, send out 4 outside. Sin t dt. Sin t dt. What is integral sin t? It is minus cos t. It is minus cos t. 1 by 4 into, in the place of t you have to put tan inverse x power 4. Tan inverse x power 4. 1 by 4 into minus cos t. In the place of t you have to put tan inverse x power 4 plus 1 by 4 into minus cos tan inverse x power 4 plus. See the steps up carefully. Okay, now let us move to next question. Now let us see the next question. Integral. It is objective question. See here. Integral 10x power 9. 10x power 9 plus 10 power x. It is also looks complicated but very much easy. It is 10x power 9 plus 10 power x. 10 power x log 10 to the base e. Log 10 to the base e. Log 10 to the base e by x power 10 plus 10 power x plus 10 power x. See the question here, and there are 4 options. See the options here. A, it is 10 power x minus x power 10. Next, 10 power x plus x power 10. Next, 10 power x minus x power d log of 10 power x plus x power 10. By completion of this chapter, you will be in a position to say the answer without calculating a single step. By finishing of this chapter, this kind of sums you can solve without solving. By seeing the option itself, you can say the answer. But we are in the initial position. Let us take a stepwise and solve this question. Okay? See, what thing we have to assume as t here? What thing we have to assume as t here? See here, if we assume the denominator as t. If we assume the denominator as t, what will be the derivative of x power 10? It is 10x power 9 plus, what is the derivative of 10 power x? It is of the form a power x. It will be 10 power x into log a. Don't bother about e. The formulas which we are given log, for them the base is e. Here in the question they mentioned e, but in our formulas we have not mentioned the base. It means that the base itself is e. Generally, logs whose base are e is not mentioned generally. Okay, don't get confused with e base. Okay, now let us assume the denominator as t and proceed. See here, if we assume x power 10 plus 10 power x as t, let us assume x power 10 plus 10 power x as t. Now what is the applied derivative on both sides with respect to variables? X power 10, it is 10 into x power 9 plus derivative of 10 power x, it is of the form a power x. What is the derivative of a power x? It is a power x log a. In the same way, for 10 power x, it is 10 power x log 10. 10 power x log 10 into dx equals to dt, into dx equals to dt. Derivative of x power 10, it is 10x power 9 plus, for 10 power x it is of the form a power x, for a power x it is a power x log a. 10 power x it is 10 power x log 10 into dx. See here it is dx. See here we require this thing. 10 into x power 9 plus 10 power x log 10. See, this is we got directly. In the place of this total numerator, we can substitute dt. We can substitute dt. In denominator, it is equals to t. In the denominator, it is equals to t. It is of the form 1 by x. It is of the form 1 by x. What is the integration for 1 by x? It is log x. It is log x. For integral 1 by t, it is log t. It is log t plus c. It is log t plus c. What we assumed as t? We thought that t equals to x power 10 plus 10 power x. Substitute the value. In the place of 10, t, substitute the value. X power 10 plus, substitute the value of t in the given equation. Log of x power 10 plus 10 power x. By end of this chapter, you will be in a position to say the answer directly without solving a single step. Okay? What is the correct option for this question? It is option D.
But integration detail must be equal to.
See the next question here. See the next question here. That in 9th question. Okay. Actually, substitution is nowhere. Without substitution, also we can solve this problem. But this in this exercise, it was given in this exercise. Okay. Without substitution, also we can solve the given problem. Okay. See the question here. Integral sine cube. Integral sine cube x cos square x. Integral sine cube x cos square x dx. Okay. See integral sine cube x cos square x dx. Here we need little bit trigonometry. So here by substitution we will solve this question, but which thing we have to take it as t? If we take sine cube x as t, then its derivative is 3 sine square x cos x. So we cannot convert the total into t. If we assume cos square x as t, we cannot convert total into t. If we assume sine x as t, then it will become t cube. Derivative of sin x, it is cos x dx, but here it is not cos x dx. So let us solve for some step trigonometrically, and after that we will observe the function and we will decide which thing we have to take as substitution. Okay. See here, you all know the trigonometrical identities. Sin cube x we can split it as sin x into sin square x. Sin cube x we can split into sin x into sin square x. Because why we are splitting like this is, sin square and cos square are interconvertible. One thing can be converted into other by using the identity. Sin cube I was writing like this: sin x into sin square x into cos square x dx into cos square x dx. See here, let us calculate the further steps in mind. In the place of sin square x, if we put 1 minus cos square x, 1 minus cos square x, then the total will be in terms of cos. This total can be in terms of cos. In that, if we assume cos x as t, sin x dx it will be dt. Sin x dx it will be dt. So what we have to do here? We have to convert sin square x into cos square x. What is the identity here? We have to convert sin square into cos square. 1 minus cos square x. 1 minus cos square x into cos square x dx. What we are doing here? In the place of sin square x, we are putting 1 minus cos square x. Our motto is to convert, except the sin x, our motto is to convert the total function in terms of cos. In terms of cos. Okay? Now multiply this cos square x into 1. It is sin x into cos square x into cos square x minus cos square x into cos square x. It is cos power 4x. It is cos power 4x dx. Cos power 4x dx into dx. See here, now split the integral here. Integral cos square x sin x. Integral cos square x sin x minus. Otherwise, you can here you can do in two ways also. Directly you can assume cos x as t. You can directly assume cos x as t, and this will become dt. It will be t square minus t power 4. Like that also you can do. Otherwise you can split the integral and you can also do. Okay? See here. Here, okay, you do in this only. Assume cos x as t. Like this also we can solve. Okay, we proceeded here now. We will follow this. Continue here. Cos square x into sin x minus cos power 4x into sin x. The answer will be same whatever the procedure we follow. See here, cos square x into sin x minus cos power 4x into sin x. Here, assume in both integrals, assume cos x as t. Assume cos x as t. Assume cos x as t. If we assume cos x as t, apply derivative on both sides with respect to variables, minus sin x dx equals to dt. What is the derivative on both sides? What is the derivative of cos x? It is minus sin x dx. Minus sin x dx equals to dt. Here we follow. Here dx will come to both integrals. Here dx will comes to both integrals. See here. Here we require sin x dx. Here we require sin x dx. From this we can conclude that sin x dx equals to minus dt. Sin x dx equals to minus dt. See here, I was converting the function in terms of t. See carefully. Converting the given function in terms of t. In place of cos x we can put t. T square. T square. In the place of sin x dx. In the place of sin x dx, it is equals to minus dt. I was taking minus common. Be careful. Sin x dx it is equals to minus dt. I was taking minus. Okay, let's put there only. Yeah? Minus dt minus integral. In the place of cos x t power 4. In the place of sin x dx. In the place of sin x dx. What you have tried? You have tried minus dt. It will become plus dt. It is plus dt. Otherwise take minus at a time common here. You can take minus at a time common. If you take minus common, integral. Here it is t square dt. Here it is t square dt. Next. Here. If you take 1 minus as common, here minus integral t power 4 dt. Integral t power 4 dt. What formula you have to apply here? Integral x power n. What is the formula for integral x power n? It is x power n plus 1 by n plus 1. It is integral x power n plus 1 by n plus 1. It is t power 2 plus 1 by 2 plus 1 minus t power 4 plus 1 by 4 plus 1. We are applying the formula of integration. You have to put C. See here, sign minus inside t power 3 by 3 plus t power 5 by 5. T power 5 by 5 minus t power 3 by 3 plus t power 5 by 5. What we have assumed in place of t, we assume cos x. Put the value minus cos x whole cube by 3 plus cos x whole power 5 by 5 plus C. It will get carried. Okay. See the steps here carefully. We solved for first 2-3 steps. We solved trigonometrically. Sin cube x, we have written sin x into sin square x. In the place of sin square x, we can put 1 minus cos square x. Our main motto is to convert, except the sign, we have to convert the function in terms of cos. Because if you assume cos as t, we are getting here dt and total we will convert in terms of t. That is the main motto. That's why in the place of sin square we are converting in cos. Okay. See the steps, huh? Now, here we did many sums on substitution method. Now, let us do some sums by using trigonometrical identities. By using some trigonometrical identities. Here also we made many questions while solving we use the trigonometrical functions. But here are some more sums which are mainly based on trigonometry. Okay. Before going to next concept, you should be thorough with trigonometric functions. Next. See the question here. Secant square secant square 7 minus 4x dx. Okay, see here we can solve this in two ways. Assume 7 minus 4x as t. Assume 7 minus 4x as t. Otherwise you can do directly also. It is of the form ax plus b. Assume this as x. What is secant square x? It is tan x. It is tan x. You can do directly also. Okay. Otherwise by substitution also you can do. Dx. Here let us solve by substitution method. Assume 7 minus 4x as t. Apply derivative on both sides. Apply derivative on both sides. It is minus 4 dx. It is minus 4 dx equals to dt. It is equals to dt. In the place of 7 minus 4x, we have to put t. In the place of dx, we have to put like this. Take minus 1 by 4 as common. What is integral secant square t? What is integral secant square t? It is tan t. It is tan t. Minus 1 by 4 in the place of t. Tan 7 minus 4x. 7 minus 4x. Minus 1 by 4 tan 7 minus 4x. Okay. Okay, we will continue in the next class. Sir.